let's just summarize our product law, quotient law, power law. So again, if we have a logarithm where we're adding two logarithms that have the same base, we can take the arguments and multiply them in one logarithm. Similarly, with the quotient law, if we're subtracting two logarithms with the same base, we can take the arguments and divide them. Just remember, we're going in order from left to right. So the first term is always your numerator. And then lastly, the power law. We have the exponent n. That can be rewritten as a coefficient in front of the log. So putting these all together, we're now going to use a combination of laws to do a question that we've already answered. You guys remember this one? Okay, where we factored out the 3, then we got a logarithm and we subbed in p over q. Now we're going to use the power law to solve this. Okay, so what can I do with those 3's out front? Good, I can use the power law and make them the exponents. So I would end up with log 2 p to the power of 3 minus log base 2 q to the power of 3. So first I applied the power law. Then we're going to take this, and we're subtracting two logarithms with the same base, so I can use the quotient law. So if I do that, I get log base 2 p cubed over q cubed. What can I do with the cube on both the p and the q? It doesn't cancel because they're not the same base. Can't subtract them because they're not the same base, but I can rewrite it like this: p over q to the power of 3. Where the power of 3 would be applied to both the p and the q. They tell us that p over q is equal to 8, so let's just sub that in. Get log base 2 of 8 to the power of 3. Can we use the power law again? Okay, we're going to apply the power law to that 3. And then I'll get 3 out front, logarithm 2 of argument 8. And if I evaluate this logarithm, 2 to the power of what gives me 8? 3. So I get 9. So you can decide whether you want to factor out the 3 and just right away use the quotient law, or if you want to get creative, you can do way more steps and use the power law, the quotient law, the power law again, and then sub in. So it's just showing that you can solve that question either way. Both are correct. One is just a little bit longer. This one. Just a little bit. Okay, next one we're going to write as a single log. We're looking at the 1 over 2 and the 1 over 3 out front. What should I use first? Power law. Good. Okay, let's write those as exponents. So I get log base a 16 to the power of a half minus log base a 8 to the power of 1/3. Just on the side here, 16 to the power of half. What's another way of writing that?
Square root of 16.
Good, the square root of 16. Those are identical. One has a square root, one has an exponent. So we have log base a square root of 16 minus log base a 1 over 3 as an exponent can be written how as a radical? Cube root, good. Cube root of 8. And you can decide to write it like that, or you can just evaluate right away. So cleaning this up one more step. Square root of 16 is 4. Cube root of 8 is 2. Now that I have a subtraction sentence, I can just apply the quotient law. And I get log base A 4 over 2. Okay, just dividing those arguments. And I end up with log base A argument 2. So there's my single log. Now what if A equals 32 for part B? Just sub that in. And there's two ways you could solve this. You could go log 2 divided by log 32, or you could solve it using exponents. 32 to the power of x equals 2. We need the same base, so we're going to set 32 to be 2 to the power of 5. And so we get 5x equals 1. Okay, same base, we take the exponents, 5x, and set them equal to equal 1. Sorry if it's a bit low. And then just divide by 5. If you ever forget these steps or you freeze up, just remember you can go log 2 divided by log 32, and you'll get 1/5, or 0.2. Okay, just looking at A, anyone know the answer? So example 3A. Think it's 1? Got some 3s, some 1s, some 0s. Let's find out. Can I rewrite this using the power law? Okay, I get log x cubed minus log x cubed. Anything minus itself? 0. Good job to those zeros out there. I'm not calling you nothing, don't worry. Okay, part B. You can do one of two things. You can apply the power law to start, or you can factor out a 2. I'm just going to take a 2 out. Why not? Okay, same base. What do I do with the arguments? Take product law. I multiply the arguments. So I get 2 times log 10. What's this imaginary base? And if I have the same base and say got the same argument, what does it equal? Well, this part equals 1. 2 times 1 is 2. Good. And this next one, without using a calculator, how are we going to do this? Think about strategies. We've done an example where we had to be creative. Right now it's the quotient of the quotient law. So we separate them into 2 terms. So log base 3, we're going to take the numerator and write that as our first argument. We're going to subtract log base 3 of our denominator, which will be the second argument. First we applied the quotient law. Now we're going to use the product law. And we're going to take those exponents and just put them out front. Okay, so 3 will go out front. We got log 327 minus 4 log base 3 argument 81. So we have 3 times what? What's the value of log base 3 27? In other words, 3 to the power of what gives me 27? 3. And for this logarithm, 3 to the power of what gives me 81? 4. Okay, and if we evaluate that, we should get -7. Questions? No? You sure? Okay. Have I made a mistake?
No.
Okay. Just making sure. Alright, class example number 4. They're telling us that log base 2 argument x equals a. We need to find the expression for this logarithm. So we're going to first give a hint of what they've told us. And we're going to convert that into exponential form. We get 2 to the power of a equals x. Now in the expression that they're giving us, we have an x, so we can replace 2 to the power of a for our x here. So sub it for x. So we get log base 2, 16 times 2 to the power of a, that's going to replace our x to the power of 2. And typically when they say determine an expression, they mean find the simplest form. So let's just clean things up a little bit. Log base 2, 16 times 2 to the power of 2a. Is there any way that we could perhaps get the same base? What could 16 be rewritten as? 2 to the power of 4? Good. And whenever we have the same base, so this is just our argument right here. Okay, when we have the same base, what can I do with the exponents? We add the exponents. And we get log base 2, 2 to the power of 4 plus 2a. And I just want to point out here, I have a base 2 and I have an argument 2, but I still have that exponent. So if you have the same base as argument, what's the answer going to be? The exponent. But we can use the power law just so you can see that a little bit better. So by applying the power law, I get 4 plus 2a multiplied by log base 2 argument 2. And when you have the same base and argument, that just equals 1. So your answer is 4 plus 2a. This is work 1. Okay, for this last one, then we're done. No quiz today. Well, I'm not going to give you 5 minutes to do your quiz, don't worry. Okay, do we have the same base for every single logarithm?
No. Yes. Oh, sorry.
Same base.
Oh, sorry. Yeah.
Okay, base 10, base 10, base 10, base 10, base 10. So if they all have the same base, we can apply our product and quotient laws. Okay, and I know that because we're adding and subtracting, so I would apply the product or quotient law. Okay, before we do that though, we have a few coefficients out front, so let's just use the power law so that they are written as exponents. And then following the order from left to right, we'll have log base 10. And our argument will be b multiplied by d. We're subtracting, so e to the power 5 will be in the denominator. We're subtracting log a squared, so the a squared will also be in the denominator. And then we're adding log a to the power of 1/2, so the a to the power of 1/2 will be in the numerator. Then we just have to clean things up. We get bd over e to the power of 5. And what's happening with our a's? If you have the same base, and you're dividing, what do you do with the exponents? Subtract. So we have 1/2 minus 2, so that's negative 3 over 2. This is negative 1.5. So if it's negative, that means we want to put it in the denominator, a to the power of 3 over 2, as a positive. And that's about as simple as it can get. We went from 5 logarithms to 1. And I'll say it again.